Phil, please stand up and talk about the orchestration of this and where this goes.
Yeah, I hate to follow Sarisa, but I have to challenge you on one supposition, and that is that Craig was working and his son was gaming. No, I think Craig was gaming and his son was working. Anyway, Anyway, my name's Phil Fine, and I'm an amateur explorer, but I happen to be tagged to talk to you a little bit about AI. And the one acronym I don't use here about AI is it's PFM. So it's pure magic, okay? I'm not the expert at Ciena. I've got a lot of really much smarter folks behind me that gave me some insights into AI. We have been doing some proofs of concepts, and we've been using digital twins to identify how to solve issues that have taken, in some cases, hours in the real world. So I'll take you just a little bit deeper on a few concepts that Sarisa brought up, and then we'll follow with the really smart people. But my focus is going to be strictly on AI. There's a couple of techniques that you'll hear about. Sarisa kind of mentioned RAG. I'll talk about that. She talked about agentic AI. I'll talk a little bit about that. But what's the real problem we're trying to solve, and how does AI assist with AI operations? Specifically in our domain, we were looking across an optical network that also had some access components to it, like virtual BNG and PON network components. But as we dug into this, we thought about, what are the real two areas that we can enhance with AI? One, of course, is operational efficiency, and that's where I'll focus a little bit more here. There's obviously some CapEx things that can be done. You may be planning a network and want to figure out where do you want to build out to. Maybe you're taking in demand generation, but you don't want to do a dig, you want to do aerial. So you pick an area that's better suited for the topology. But I'm going to focus more on the OpEx in and around assurance and troubleshooting, and we'll talk a little bit about what Sarisa mentioned with respect to building trust in the data models and how much do you really want to make the network autonomous. We're not quite there yet, but we'll show you a little bit about how you can move in that direction. A lot of uses in and around optimizing the use of the network, and then ultimately, autonomy once you've built the trust in the models that you've started to build. But AI ops is certainly going to be able to make your operations more efficient. Again, we'll talk about a couple of use cases where we've proven that out. There are three areas to consider for AI ops. One, it's something that I know you're all quite familiar with if you're building networks, is how do you build a network for AI? Because what you need is a lot of bandwidth and very low latency, and you're connecting data from literally all over the world. You want to be able to get that data to and from the queries that are part of the AI prompts to solve the problem. So building the network, not going to focus on that. There's a second piece is how do you address the network operations? And again, Sarisa introduced the concepts. We'll dig in just a little bit deeper here. And then there's AI for engineering. We're not going to go there, but again, building the networks, optimizing where you go and do the builds. AI can also play a role there. But if we focus really on AI for operations or AI ops, if we look at the data sources that you get information from, whether it's your device element management systems, whether it's the OSs themselves, whether it's multi-domain network management layers from the BSS, from the OSS, from demographics, if you want to go build in areas, from weather, if you want to figure out that you've got failed components due to weather patterns. I mean, there's just an enormous amount of data source to get there. And I think that's one of the challenges, right, is the amount of data, what of the data is important, and that's where AI can really help quite a bit. So if you look at the term AI ops that was coined by Gartner, we're talking about applying machine learning, generative AI, RAG AI to solving problems that humans try to solve, but it takes a lot more time for them to figure things out. So everything's driven by big data. the amount of data that's out there is it's so large that humans typically can't take advantage of it. And it's not only historical data, or it may be documentation, or it may be real-time streams from logs, from alarms, from performance data, just an enormous amount of information to sift through that typically can lead to a level of operational insight. And where the magic comes in is, how do you take that and start making decisions on it, and ultimately moving towards full automation. So some of the use cases, network planning, of course, we talked a little bit about that. I'll focus a little bit more on network assurance and a couple of proofs of concept and real world digital twin analysis that we've done. Optimization of networks, and then into full automation if and when that makes sense. So we'll go into really more of the network assurance side in the following slides. But we'll start with this thing you'll hear called RAG, or Retrieval Augmented Generation, or RAG AI. Think of this as being a static source of information. So anybody who's gone to the internet now and does a search is going to get some kind of AI results. That's typically static information. It's almost like going to a library and looking through, I mean, if anybody's as old as I am, the old Dewey Decimal System, and you can go and get those books, but there's no real analysis. It'll help you find what you need, but it's really static information. But what happens is it takes all this raw data, kind of cleans it up, and puts it in a vector DB, right? Now, I don't understand the magic of all of this, but what I do remember is there are ways in vector analysis where you'll basically use cosines to figure out, how close to zero angle or 180 degrees. So this data is brought in. It's made available in a way where an operator can use a natural language query. What's up with my network, or why is my wife having problems with the internet? And that goes into an orchestrator, and that orchestrator is basically pulling information from this augmented database. It's taking that out, and through these queries, it's learning. Basically, it's learning on that query what's coming back from these databases, and depending on how the queries formed, the large language model can leverage that information and refine it, and ultimately return some kind of a recommendation if you're not at the point of getting to full automation. But we'll talk about that in the second AI concept. But anyway, this is static information, but it's very helpful. Again, most of what I've learned on AI is by using AI to learn something about AI. And I think everybody's gone there where they've learned something using AI. That and TikTok, but that's all different. So I'm going to talk about a second part of this, which is agentic AI. And if we look at, how do the humans normally work? The network engineer, they have an issue in their network, and they've got a bunch of data sources at, layer 0, 1, 2, 4, all the way up the stack. And, they're trying to figure out what's going on. And of course, if anybody's gone through this process, you spend 20 hours to find the problem. And in hindsight, it would have taken you about 30 seconds to solve the problem. I mean, think about, a duplicate IP address in your network. I mean, it's the most nightmarish thing to figure out, because some application works sometimes, and then it stops, and then it works again, and you're like, what's going on? So, I mean, we're talking about a lot of human cycles to get things done. And then the engineer provides some result, and based on their own experience, which they just learned, what do you do the next time? And then if that engineer leaves, you lose that knowledge. So what we tried to do, and what we're trying to do within our company, is build, an agent that mimics what a network engineer would do. And we're trying to do this by learning on our own as we build the models that will help solve some of the problems. So if we look at AI, there's kind of two components. There's the large language model, that's where the brain is. And then the tools are taking that information and making sense of what's going on in the network. Digging down one level, so we talked about RAG AI. RAG AI can play a very important role within your network. For one thing, anybody who's worked with documents are like, oh, you got to have everything documented. And then there's so many documents out there, you can't find the information that's relevant. So RAG will always play an important part in solving network problems because each vendor's got their own way of doing things. You just want to know, how do I resolve this problem, right? Whatever it happens to be. But what agentic AI does is it now adds real-time information from a number of data sources, right? Whether it's the network equipment itself, whether it's your billing and operation support system. It can be from databases, from alarms, from events, from almost any place you can imagine and you wouldn't even think of. So just tangentially related information, like I said, weather patterns that might affect component lifetime. Takes all this information, and over time, these language models can learn, right? And you can add more information. I think Sarisa talked about, well, if you, let's say you've identified some issue in the access network, well, you could bring in further information from in-home to really figure out, is the problem that the customer is complaining about, is it the network or is it something that's going on in the home? So it's an iterative process. It's about building the trust. It's about, seeing that I'm seeing consistent results come back. I mean, we've seen some patterns where, sometimes you'll get slightly different results that come back from queries, and then you learn that, well, that is a ghost that's out there that doesn't really have an impact on the recommendations. Everything's based on natural language, right? If I can just say what's wrong with my network, life's great, right? And as Sarisa said, you can fully automate. It's highly unlikely you're going to try to fully automate everything because the next thing you know, your whole network goes down. But if you can really quickly identify the problem, you can save a lot on OpEx. So what are some of the exemplary use cases? By the way, these screens on the right are from some real debugs that we've done so that you can see all the steps that the agents have taken. That's part of building the trust. But ultimately, you want to get rid of that, and you just want to at the end say, hey, you had a problem, here's the results, right? So where should I deploy services to maximize profitability, right? You may take topological information, demographic information, demand that's coming in if you're doing that. So you can optimize where you deploy your network resources. Or what services were impacted with a recent PON failure. We did some proof of concept with type B PON protection on a disaggregated network. You get an alarm in, there's a problem. First thing you're going to do is you're going to hightail it to go fix the problem, when what you can do with AI is find out, well, that's a protected leg, so you don't really have to rush. You've got the service up and running. Real world use case like that. We've seen use cases where misconfigurations of a BNG, so if you have a virtual routing function misconfigured, nightmare, like the duplicate IP address in a network you can't find. Or what silent failures. Customer calls in, says I have a problem. AI is very good at helping kind of isolate what the root cause of the problem is. So just a couple of takeaways. A lot out there, AI ops, again, helping you really reduce the time to resolve problems. One real world use case I wanted to mention is we did have a customer who had a misconfigured virtual routing function. Took them 20 hours to figure out the problem. So we brought back, modeled their network, and we ran AI, and ultimately, once the model was trained up, it took 12 minutes. And you're not going to always see that kind of result, but if you start to leverage the tool, it can reduce the amount of effort. And that's relying on big data, on kind of this machine learning, on getting feedback from the engineers so that you can train the models. And there are just an enormous numbers of scenarios out there. But as Sarisa said, you're probably going to want to try to find those problems that happen most frequently and would reduce the effort as much as possible. And then just having that natural language out there is critical because as one of our customers said is some of my folks literally can't read. Can you just give me a red light when there's a problem? Don't know that that's always true, But I think everything we can do to reduce the amount of human effort allows you to scale your resources better. So thank you.
Thank you, Phil. And while Eric comes up, I just that whole building trust theme, I definitely want to touch upon that when we get into the questions. So